And we're live. All yours, Yuval.
All right, very nice. So this is our third episode in Hoot, where we review service measures. I'm Yuval Kuhavi. I'm an engineer here at solo.io, and let's start today's episode. So in the previous episodes, we had the first one, and they're all recorded. You can watch the previous episodes on YouTube. We had Christian Poster talking about Istio, and Rick was talking about Linkerd. And the goal of this series is to give the community some knowledge and insight about the different service meshes out there, the trade-offs, what are they good for, and do a quick demo so you kind of get the feel of how to run them. And on this episode, we'll focus on Consul Connect. And I'll be looking at the chat. If anybody has any questions, feel free to write them anytime, and I'll try to answer them as they come about. So first, a little bit of introduction to Consul. What's Consul? Consul is a tool written by HashiCorp, and you can check out their website. They have excellent documentation, which we'll review shortly. HashiCorp.com/Consul. It's a tool that's originally designed to help organizations transition monolith into microservices. And the way they do that is by providing facilities that were easy in the monolith world, but were missing in the microservices world. So initially, as Consul was developed, it had two main features. Service discovery, and that also includes registry, health checking, all that, and configuration, a key value store. Let me go a bit about those. So originally, when you install Consul, imagine you just transitioned from your monolith to a microservice, and you probably had an auto-scaling group on Amazon with EC2, and you build your immutable images in CI, and essentially a similar concept to Pulse today in Kubernetes, but in VMs. So once you break your monolith, there are certain things that used to be easy that are now harder. For example, what used to be a function call to a different module in the monolith is now a network call. And the question is network call to where? And that's the question this service discovery feature in Consul helps answer. So, for example, service A could query Consul about the location of service B, and Consul would provide service A with the healthy instances of service B, right? So the question is, how does Consul know what are the instances of service B? And that part is service registration. And the way that works is actually a very similar concept to a sidecar container, but again, in the world of VMs, each VM would have the Consul agent installed in it, and the Consul agent would report to the Consul control plane, essentially the Consul master, that a new instance has come alive and register him to be available for service discovery. Good. So essentially, you'd bake this agent onto your VM image, and when the VM starts, everything would just happen automatically. And then when service A queries for service B, you would get all the instances of service B. And that model of baking the agent to a VM is conceptually similar of injecting a sidecar into a pod, if we'll go back to the Istio way of doing things. And you can hear more about that in the first episode by Christian Posta. So that's service registry, discovery, health checks. Consul would actually monitor everything and make sure each application could get to the instances of the service it depends on. Now, the second functionality that Consul provides is a key value store. Similar to etcd, for example, if in the past configuration was a single configuration file consumed by the monolith, now where everything is distributed, the configuration needs to be handled as well, right? So Consul allows you to have a single key value store that the operator can update the configuration, and that would propagate to the whole of the Consul cluster. Now, the way Consul is architected is you have a set, usually between 1 to 5 of master nodes. There's one, leader elected, and every VM has an agent that the application talks to that agent, and the agent talks to the master nodes. And that agent can cache a lot of things to make the access faster. So the key to get configuration values, the application could query its local agent and see how it needs to be configured. Right, so far, if anybody has any questions about that part, it's kind of like an intro to Consul. There's a lot of videos that go into details on this. I just want to give a brief introduction, and if anybody has any questions, feel free to ask now. All right, so recently Consul added a feature called Consul Connect, which will be the main focus of our talk, and depending on time, we'll see how much deep we can go into it. And the idea with Consul Connect is to solve an additional problem, which is identity, security, and segmentation. So the problem is that, right now service A can talk to service B, but it can also talk to service C, right? And maybe it's not allowed to talk to service C, right? If we'll take a classic, 3-tier application where you have a web layer talking to a business layer and talking to the storage layer, you don't want the web layer talking directly to the storage layer, right? You want to segment your network such that services are only allowed to talk to the entity they're allowed to talk to, right? And that's what Consul Connect solves. So Consul Connect is the service mesh feature of Consul, and it builds on top of the service registry that Consul already has, and allows you to establish a mesh based on your existing Consul deployment. Now, the nice thing about Consul Connect, if we kind of contrast it to other solutions, that it works inside Kubernetes or outside Kubernetes and has some integration with service discovery such that Consul services outside the cluster can access services inside the cluster and vice versa. And it's pretty lightweight to configure. And we'll see a demo. We'll see how we install and configure it in this little mini cube I have set up here. And it allows you to, if you already have your Consul environment, to continue have it, you don't have to pay migration costs to change something new and shiny, and continue and re-leverage your existing implementation. All right, so, and again, if there are any questions, feel free to ping them on the YouTube chat. All right, so the way Consul works in Kubernetes is very similar to how it works outside Kubernetes. In a second now, when we'll start the demo, we will install Consul to Kubernetes via the official HashiCorp Helm chart. And you will see that it deploys the Consul agent as a daemon set. It deploys the Consul masters as a stateful set. And it will create a sidecar injector to inject the Consul sidecar so it forms a mesh. Now, the way the Consul mesh works, essentially, how does Consul implement this segmentation, right? So service segmentation has two parts to it, right? First is service identity, right? In order to say A can talk to B, you first need to know who is A and who is B. And the other one is that policy. You can say, A can talk to B, and you need a language to express that. The identity part is solved using MTLS and client certificates, very similar to how it's done in Istio and Linkerd. So and as we'll see in our demo, when a pod is provisioned, a sidecar proxy is also provisioned with the pod. And Consul has a few ways of integrating an application into the Consul mesh. So there's first, you can use the Consul native proxy. It's a proxy that they wrote in Go, and it comes out of the box. And the main advantage of it, it's very easy to use, right? It just works. And recently, they also added support for Envoy proxy, I believe starting the 1.5 release. So there's also built-in support to running Envoy as a sidecar proxy. When Consul Connect first was released, we had our own Glue Envoy integration that provided Envoy as a sidecar in addition to the initial proxy. There was the Glue Envoy integration from us, from Solo. And now that they have the built-in support, you can just use that. And the other option is to write your own proxy, right? If you like HA proxy or if you like Nginx, they don't have an official, Nginx integration, but they have the documentation that you can follow and integrate your own proxy. So they're very flexible in that sense, right? They can tell you, if you follow this task or this spec, you can integrate your own proxy into the mesh. And that, if there's a proxy that your organization is familiar with, that you have knowledge, this could be a nice option for you, that you don't have to learn something new. Envoy is a great proxy, but it does come with a learning curve. You do need to learn how to configure and operate Envoy. And the last option is that an application can natively integrate into Consul. And if you have a Go application, that's actually pretty easy. They provide a library that you essentially need to use their library to make connections. And this library will, do the Consul connect heavy lifting and make sure your application is in the mesh. Now, using a library comes with its own trade-offs. Mainly that it's kind of why Service Mesh as a product was started to begin with, right? So if the Service Mesh precursor, the Finagle library, a Java library, and the problem with the library is that it's, compiled in the application. To change it, you have to redeploy the application, unlike with the sidecar model where you just have to redeploy the pod. There's no code changes. You don't need to redeploy a new application binary. So there's pros and cons, but with Consul, you can do any option you choose, essentially. Whatever works for you, you might decide that managing a sidecar proxy is too operationally complex and you have Go infrastructure anyway and might as well use their Go client library to get those mesh features. So that's, connect-aware applications. All right, so these are the options that are available to you for a mesh. In this demo, and we'll deploy Consul into our Minikube here, and we'll look, how we look at all the components. In this demo, Envoy is used as a sidecar. And the way it works is that when the pod is started, an Envoy sidecar is injected to the pod. The Envoy sidecar communicates with the local Consul agent, very similar to how it works today, and or very similar to how Consul works outside the Kubernetes cluster, rather. It will get a certificate to be used as its identity, right? And the certificate never leaves the node. The local agent manages it, so it never travels over the network. And this certificate will be used to establish identity. And now every time every time the application will go upstream, it will go through the proxy, and we'll see how it's done in Consul. It's not exactly the same way it's done in Istio and Linkerd, namely there's no IP tables magic. And it'll go through the application goes through Envoy, it'll go through another proxy in the other sidecar in the destination, which will end up in the service, which is pretty much how you've seen it in the Linkerd and Istio demos. All right, so unless there's any question, I'm gonna start deploying. And in this part, we like to cross our fingers that everything will work as expected. So I have here a little Jupyter notebook with all the commands, and I'm essentially following the Consul Kubernetes guide, which is here, Consul on Minikube via Helm. I just wrote all the commands in Jupyter Lab, so it's reproducible for me to just run them. But if you want to follow along, you can just go to learn.hashicorp.com/consul/kubernetes/minikube. And that's essentially what we'll be doing. We'll go into a bit more depth than in this document, but you can use this as a reference. So the first thing is to install Consul, and we install it with connect, inject enabled. So let's do that. All right. We should kubectl get pods, see it running. And of course not. There we go. So it's creating and it's running. Great. So we now have Consul installed. And now let's look at the various components. Let me make this a bit bigger here. All right. So we see that the Consul agent was installed as a daemon set. We see there's a webhook to inject the Consul sidecar. We'll get to that in a sec. And you don't see it here, but if we look at stateful set, we'll see the Consul server deployed as a stateful set. Oh, actually, you do see it here. Never mind. All right. So we have Consul deployed to the cluster. Everything seems to be running fine. All the pods are in steady state. Good. So now we can kubectl port forward to access the Consul UI. Consul comes by default with a nice UI where you can see what's going on. All right. So this should be this UI. All right. So this is the Consul UI, and as we'll deploy the services, they will register into Consul and will appear in the services screen. Let's go back to the notebook, deploy service A, and it's a service from their demo. It's the counting service, and there will be two services. This is the backend service. It holds a counter and will connect it to a dashboard service that displays the counter. So do note that in addition to deploying the service itself, we're also deploying a service account. In Kubernetes, service accounts are used as a source of identity. So having a unique service account is important because that way you can have a unique identity for each service. So let's deploy that. All right. let's see what's going on. Good, it's running. So let's see what we have here. Let's just clear the screen. Let's look at this pod. So we have the counting pod. And if you look at the deployment, you see that we annotated it with injection true. And let's see what happened. All right. So we have here the list of containers. First is the counting container. That's our application. That's what we expect. The second container is the Consul Connect Envoy sidecar. So this sidecar it's the sidecar that the communication goes through. All right. And the last container is the lifecycle sidecar, and that's responsible for registering and unregistering things from the Consul local agent. That's to help Consul maintain its registry. All right. So far, so good. Everything is ready and nothing crashed. Thank you, demo gods. And we can go on and continue deploying the second service. Oh, before we'll do that, let's just check the Consul UI. As you can see, counting service and the sidecar proxy appear in the services, and health checks are passing, so everything's good as expected. All right, let's deploy service B. And service B is very similar. It has its own service account, and the deployment will deploy the dashboard service. And what's interesting about this deployment is here you can see how Consul Connect Mesh works in practice. So in order for the mesh to work, unlike Istio and Linkerd, they don't do IP tables magic. What they do instead is when you deploy an application, you specify the upstream services it needs to access. So what this annotation here means, it means that we want to make the counting upstream service available to this pod, and we want to expose it on localhost on port 9001. So it's a bit confusing. That's not the port of the counting service. That's the local port in which the counting service will be available for the dashboard service. And you can see here that the counting service URL is HTTP localhost 9001. And do notice HTTP, not HTTPS, because the dashboard service will connect as if there's no mesh, and the sidecar proxy that listens on this address will add the TLS and the identity of the dashboard service as it sends the request upstream. So let's apply this one. All right, it's working. It's initializing. Let's give it a sec. Good, good, good. And we can see them starting up. It's not passing, but okay, yeah, just took a second there. Everything's deployed and running. Great. So now we have the dashboard service deployed and connected to the counter service. All right, we'll proxy to the dashboard service and open a tab for it. And as you can see, we are connected to the dashboard service, and this one counter is retrieved from the counting service. So as we refresh, the counter increases. And I think there's some JavaScript here that increases it regardless. All right. So let's do a quick recap of what we have so far before we go to intentions. So we have the Consul servers that are, there's leader election, usually between one server, 3 or 5. So if one of them fails, you still be, or if there's a network partition, rather, you still be able to have quorum. Those servers, if we look at the pods, so this is our single instance Consul server. The Consul node agent, which is this one here. It's deployed as a daemon set, one on each Kubernetes node. And then the two microservices, the counting and the dashboard. Now let's kind of play again how it works when the dashboard service comes alive. We create a deployment. The deployment creates a pod. And when the pod, before it's admitted into Kubernetes, it's injected by this webhook. The webhook adds two sidecars, a proxy sidecar, we saw the Envoy Consul sidecar, and the lifecycle sidecar to manage registration. Now, this pod is configured with an annotation that tells it to make the counting Consul service available locally at port 9001. And what that means that when the dashboard service connect to localhost port 9001, it will go upstream to the counting service, but it will be part of the mesh, which means the connection will have the identity of the dashboard service, right? And that's expressed in TLS certificates. All right, and Consul actually has a nice diagram of summarizing this, that every node has a Consul client or the Consul agent, and they talk with the leader, and so on and so forth. Now, let's talk a little bit about the segmentation part. So right now what we have, the pod was injected, it has the proxy, the application was configured to talk to localhost 9001 instead of the Kubernetes service. This way it goes through the Consul mesh. How do we do segmentation from here? The way that works is whenever a connection is made to an upstream service, there is a TLS handshake. Usually in TLS, whenever you visit with your browser to any website that has TLS, which is almost all of them today, the server presents with a certificate that asserts its identity. In this case, and again, the same with Linkerd and Istio, what's done is a mutual TLS, which means that the client also presents a certificate. Now, as the server sees the certificate of the client, it verifies that it's indeed signed correctly by Consul. So now it trusts that the client is indeed who he says he is, and he contacts the local Consul client or the Consul agent and asks, okay, am I the receiving service allowed to receive this request from this service, right? So in this case, when dashboard makes a connection to counting service will go to Consul and tell it, hi, I'm counting. Dashboard just opened a connection to me. Am I allowed to accept it? And if it's allowed, the connection will go through. And if it's not allowed, the connecting sidecar proxy, the counting sidecar proxy will terminate the connection. And specifically in Envoy, the way it works is that they leverage the Envoy external auth, the TCP external auth filter to do that. And if we have time, we might be able to delve into the Envoy stuff. And let me just check real quick if there's any questions. Okay, we're good. All right, so let's show an example. Now the intention in Consul is very simple to add. All you do is Consul intention create a new intention, and you want to deny when dashboard talks to counting, right? So intentions is that mechanism, is that language where you express policy in Consul, right? You express that you intend for a certain service to talk to another service or not talk to another service. Now, intentions can be, default all on except deny, or the other way, default all off except allow. In this simple case, it's on except deny, and we'll demonstrate denying right now. So let's apply this one. All right, you see we created the intention, dashboard going to counting, and that will be denied. And if we'll go to the counting service, which I lost its tab, but somewhere here. Counting. Did I close it? I did. All right, so you can see that now it's unreachable. Counting service unreachable, -1, error, all of that. And everything is healthy here because it's not that the service is not healthy, it's just that it's not allowed to access. And you can see in the intentions that there is a deny intentions between the source, the dashboard, and the destination counting. All right, and we can, once we delete this intention, and this time I'll delete it through the UI, I could just as easily delete it through the command line, confirm delete. Again, everything looks fine here. But when we go, we see that it's connected again. Everything's fine. So this is network segmentation with Consul, right? Once you have each service having an identity, and each service confirming with the local agent that the connections it received actually allows to receive them best on the identity carried in the client certificate, you can achieve segmentation. Now, the way it works, all this information of the intentions is propagated from the Consul service to the Consul clients to the local node agent. So that way, a call to check if the intention, if a connection is allowed by the intention policy is a local call, right? It's a from the pod to the node agent, they're on the same node. That call doesn't go through, outside the node. So it's a very fast call. And it's also done on the TCP level, not on any request, but rather on identities, service A, service B. So it's only, let's say you have an ongoing HTTP connection, the intention check will only be performed once as the connection starts, right, on the SSL handshake process. Yes, so in that sense, it's a bit less feature rich than Istio, for example, when you can express policy on an L7 level, but it is simpler to use and easier to use and comprehend and reason about, right? You have this service allowed to talk to that service, yes or no, right? Consul has additionally L7 features for canary rollouts. We're not going to cover this today, it's just going to be a lot for one time. But you can read all about those in the Consul documentation. You have your whole section on connect and how to do with it. Yeah, but the intentions part is an L4 TCP level feature. All right. Any questions up until now? I'll check this real quick in here. So far, so good. Let me check my notes, so just make sure I covered everything. Yes. All right, so let's take a little bit a deeper look on one of the pods and see, if you ever run into a problem, how can you troubleshoot and all that. Since this is Envoy-based sidecar, the first point to look at would be that sidecar and see if it's, its statistics, if it's configured correctly. Essentially, whenever you try to solve a problem in your mesh, you kind of need to build a mental image of how the communication path is and kind of look at each component separately to determine where your issue is. So if we look at the pod counting, we can see that it has the lifecycle sidecar and the Envoy sidecar. Let's look at the Envoy sidecar. Okay. Yes, that's a deployment. Counting. There's C. And there's no bash, but there is sh. All right, so we can see right here that we have an envoy, and the envoy is indeed listed in port 9001 to accept connections coming in. And we can see that this counting service listening on port 9001 to accept connections coming in. The envoy will listen on a different port, but we don't care about that. It's essentially being handled by Consul itself as the information propagated to other sidecar proxy. We can see port 19,000, and that's the Envoy admin port. So, if you ever run into a problem, that would be a good place to start. So, for example, we can do kubectl port forward, deploy, counting 19,000. And when we go to 19,000, we can see that this is the Envoy admin interface. We can see, that it got the certs it needs to get for the MTLS, and you can see the identity of the certs. Essentially, it's the counting service. You can see various stats that can help you understand what's going on. And finally, you can see a config dump, which represents the state of Envoy as it now currently is, as the Consul agent configured it, essentially. All right. So that's the main things I wanted to cover today. I'll give a brief summary and then I'll hand it over to Betty. I'll also monitor this if there's any questions. So let's do a quick review, kind of talk about and compare a little bit. So Consul Connect, it has those features that we talked about, configuration, discovery, that are used. The main use case is when you transition from a monolith to microservices, they help you fill in the gaps. Connect was added to continue and filling in that gap security-wise, providing identity and encryption on the go as the services talk to each other transparently. We've deployed Connect to a Minikube here, deployed two services. We saw that they talk to each other through the mesh, and that was on through Envoy Proxy, though you don't, unlike Istio and Linkerd, where you have to use the mesh provided proxy. In Consul, you can use your own proxy or not use a proxy at all. You have more flexibility here. We looked over the intention system, and essentially at TCP level, service 1 can talk to service B or not talk to service B. And again, Istio has a more flexible policy language that you can describe more into details what things can do, what things cannot do. The Consul approach is that you probably don't need all of that. Service can talk. Most of the time, most of the use cases, you probably want just to say, this service can talk to that service, yes or no. All right. So we saw we can use Consul to do network segmentation in that regard. We kind of looked at how the injected pods work. We saw that it's very similar to the existing Consul model today of having a node local agent that connects to the Consul server, caches all the data, and then feeds in information to the applications running on the same node. So essentially, when a pod starts, it's injected with a sidecar and with a lifecycle sidecar and a proxy sidecar. Both of them communicate with the local Consul client, which caches everything and makes accessing data pretty fast. So if you have any concerns about speed, for example, with Istio and Mixer, Mixer is deployed in a central location, and applications have to make a network call to interact with Mixer. Istio realized that, and they're starting to support Mixer-less deployments. With Consul, it's a similar model where on every call, you got the application, sorry, not on every call, on every connection, the application needs to talk to the local agent. So that's the kind of advantage of the simpler intention model. You only need to do policy once as the connection starts and not on every request. And in addition, the policy is local. So it's a local call and not a network call, because the Consul agent is on the same node as the pod that calls to it. And it caches everything, so it doesn't need to wait for a reply from the master nodes, right? So the pod can communicate directly to the agent. So in that sense, it should be easier than a Mixer deployment in that sense. But again, each one with its own use cases. If you already have Consul in your organization, extending it to the mesh might be just the easier thing to do, and you leverage your existing knowledge as you transition into microservice, or even if you want a service mesh without microservice, you just want to encrypt stuff on the go, on the network, and you don't want to move your existing deployment structure into Kubernetes. Consul Connect can also be a great option for you. Whew. All right, and yeah, I think with that, I'll hand it over to Betty.
That's looks like we're good on questions here, Yuval. Thank you so much for doing the live stream today. And we will see folks back here in 2 weeks. We're going to cover AWS App Mesh on our next episode. Thanks.